It was a recording reminder.
Got it. Thank you. All right. So before we even get into kind of like what testing is, and you all might have seen that this is broken up into 2 days. So today, a little bit of an introduction. We'll get into test-driven development, TDD, a little bit. And then tomorrow morning, there's an hour class as well, and we'll get into testing a little bit more. This is a topic that we could spend an hour on today, and we can't cover everything in that hour. And even over those 2 hours, we still can't cover everything. But it is a very important topic. So we have 2 lessons on the calendar for this week to go over it. So today, just the basics. Tomorrow, we'll get into a little bit more of the testing mechanics. But for today, at least you should have kind of a good starter to get testing on your project as well. So let me go ahead and ask you all first. If you can open up your participants tab, can you give me a yes or a no on whether you've tried testing yet? Okay, a lot of you. And it's totally fine if you haven't. I guess I wasn't expecting anyone to have, so that's a great surprise. So those of you that are coming with some experience, this is great. You're probably already coming into this with a few questions, and you'll have time today to ask those questions. Let me go ahead and share my screen. And get my other screen set up. All right. So you should all see my slide deck right now. What I want us to do to start off, I'm going to give you 1 minute, and I want you to take a look at these 2 bullet points. So the first one here, thinking back to your capstone work, so that day 7, I think it was, in your Mod 0 work, or even what you've done so far, whether it was yesterday in class with Mike or this morning with Mike and Kat. How did you know if your program was working? What did you do to check to see if it was working the way that you wanted it to? And then that second question there, what are some potential drawbacks to that approach? So whatever approach you've been using up until now to make sure that, that your functionality is all there. So go ahead, let's take a minute just to think about that. And I'll pull you back in a little bit. But this is just on your own.
Hey, Meg. We've got someone sending a message on Slack that says they can't get in.
All right, I think Mike's gonna help Garrett get into the class. Thank you all for that. It looks like a few others. Hold on 1 second.
I'm not sure if you said Garrett, but I already got into the class. I think it was
got
somebody else who was the
Oh, I
one
see.
who wasn't able to get in.
Thanks. I did say your name. I thought it was you. Okay, I think Mike's gonna help those people out. Thank you though for letting me know about that. All right, so let me go ahead and open this up to you all. So how have you, and you can just raise your hand for this, how have you in the past tested to make sure that your code is working? Cheryl, how have you tested to make sure your code is working?
I just keep running it repeatedly and see if it works. And then if there's errors, then I work on that until it runs.
Okay, so you're running, sorry, what was that last part?
Oh, I was like, it's been really manual though. Like I just keep testing it and it's not very efficient, but
Yeah, and you mentioned you're running something. What are you running?
I'm running it in the terminal with like calling the file Ruby and then the file name.
Okay, so do you drop into a prize session? Is that what you're doing?
Sometimes.
Yeah, I think that's
Running
one
for
way that you
itself.
could do it. And I think something that you did something a little different this morning, maybe than what you've done in the past. George, what's another way that you have tested your work before?
I've used an inordinate amount of puts, which is a problem because it's not the return value, but at least I'm getting to see sort of what's happening, you know, before I knew about buy and stuff.
Yeah, totally. That's one way we've definitely done it before. It takes some time, and it also takes you kind of like weeding through what gets returned to you, right? To be able to see if it worked or not. Hope, how else have you tested?
By making a test and running that.
Yeah, by making a test. And that's what we'll talk about today. I think something else that y'all have done is make a runner file that also printed things out. Or you could have just printed something out in that file. But I think this morning I was in on Kat's lesson. She had you do a separate runner file. I see, George, you were like, no, no. And then when I said Kat's lesson, you're like, yes, we did do that, actually. I appreciate the head nods. Thank you. Okay, so why do you think, and here's that second question, what are some drawbacks to the ways we've been doing it so far? We kind of mentioned it a little bit, or a few people have mentioned it. What are some drawbacks to those?
Running the entire file can be very slow.
Yeah, it can be slow. Zach, I saw you raise your hand. Did you have something to say?
Yeah, it just gets really tedious. You have to repeat the same thing over and over again. And in testing this way, I just kind of got lost in what's working, what's not working with all this extra line of code of all my puts and all that kind of stuff.
Right, yeah. Joshua, sorry.
It's okay. So it can be a problem if, I mean, it just tells you whether or not your code is broken at times, but it maybe doesn't tell you like what you might expect as a result of your code running.
Yeah, that's great. And that's exactly what we're going to get into with testing, is this idea of like, what do we expect? And so with how you have been doing it so far, I think it's been working. You're able to see if something works or not. And what you've been working on so far is just like a very small application, right? Very small piece of code. And that's okay for right now to just see like, okay, did those 3 things maybe print out to the screen the way that I wanted them to? Sure. But what about when your application gets huge and you have to check everything that gets printed to your screen? You could have thousands, hundreds, whatever, of different things that are printed to the screen, and you'd have to go through to check all of them. So one, you could go through and check all of those, but if there ever was like something that broke, maybe you couldn't catch it just by looking at it. So that's the reason why we're testing. And so, pull this. I kind of just summarize it here. This is also in the lesson plan. It describes it a little bit more, but I just picked out kind of like the key things that I wanted you all to take away from today. So why do we test? Refactor with confidence. So when we talk, and confidence is mentioned in these first 2 bullet points. So refactor with confidence and add new features with confidence. I think these 2 go pretty hand in hand. You can add code, you can refactor your code, so you can change it up, make it a little bit more efficient, or what you think would be a little bit more efficient. And you can then run your test to make sure that it's still working, that you didn't break old pieces of functionality. I have a friend actually in my graduating cohort that slacked me, I think like a few months into his job. And he was like, hey, if anyone ever needs to understand the importance of testing, please tell them the story. And to sum up the story, it was his company did not use like client-side testing. So they didn't test like what the client would see, and they just tested the back end. And we will teach you going on into Mod 2 and further how to do that type of testing, but his company just didn't believe in it. So he made a feature. What they wanted him to do for testing is to just like open it up in the browser and make sure it worked. So he made this new feature, went to the browser. Yes, it worked, good. But what he didn't realize, since there weren't any tests, was that it actually broke the only button that contributed to their income, which was an upgrade button. And it was broken for a month, and they didn't catch it until a month. And so he had a nice talk with his boss. He still has his job, but now they're testing. So a little story of the importance of testing, making sure that you are able to make new features and that it didn't actually break old things. And then this last one here, this kind of came up a little bit, I think in this morning's lessons of you are writing code that like you might come back to months from now. You're also writing code that other people might contribute to. And testing is a great resource for developers to jump into what we would call like brownfield code that they have not written themselves. And they can take a look at like what has been tested to get an idea of what type of functionality is there without looking through all of the files. So it's a nice little roadmap for other developers to jump into your code, and also for you to remind yourself, what have I done so far? All right, and so when we talk about test-driven development, you'll hear us say TDD. What that means is test first, right? So write your tests first, and then go ahead and write your code. And the reason why we want you to write your tests first, broke it down into these kind of like 4 reasons here. Integrates writing tests into our process for creating new code. So this first one is more so like get into the habit of it. But down here are like reasons why we want to test first. So it forces us to think about what it is we actually want. And I think these two kind of come, again, these like 2 bullet points here kind of go together. Knowing what the kind of the functionality that you want, you have to think ahead of time, which is actually a reason why people don't enjoy TDD a lot of the times, is because you have to think ahead of like actually creating this code, writing this code. You have to think, okay, well, what is the problem I'm trying to solve, and how can I break it up into smaller pieces? Because as you're testing, you want to start with testing kind of like the smallest little things that you can and get bigger and bigger and bigger, and making sure that as you're adding code and as it builds off of each other, that all those little pieces are still working. And then this last one here, only write the code you need. I don't know, some of you might have noticed doing this in even your capstone work, or even in the lessons yesterday or this morning, of just kind of like writing down stuff and being like, I'm not sure if I need it, but it looks like my code is working, so I'm going to keep it there. And what testing allows you to do is, if you're testing little pieces of functionality at a time, and you get little pieces to pass like one by one, then that kind of avoids making many rows of code, right? Many lines of code that might not be doing anything actually. And so it kind of helps limit you to what you actually need in your code, instead of writing code that might not do anything, which is actually pretty common. The more you're trying to problem solve and come up with answers, sometimes you just leave code in there that doesn't actually do anything. All right, so take a look at the time, 1:13, cool. I'll give y'all a break around 25, 30. So I want to go over, there's going to be a lot of words on these 2 pages, and I'm going to kind of read over them, but I want to do an example in class, and then I'm going to let you all go into breakout rooms with just 2 or 3 people and try out another example. So don't feel like you need to write all of this down right now. It's in the introduction to testing lesson plan. And I'll kind of like hit on each of these little bullet points as we go through the examples. So testing etiquette. Within your directory, within your application that you're working on, you should always have 2 folders. One should be a lib, and one should be a test folder. So test folder, that's going to hold all of your tests. That's kind of straightforward. The lib is going to be where all of your classes are held. And this is, you're going to have many more files going into mod 2, mod 3, mod 4, and into the job, wherever you end up after Turing. But for right now, in mod 1, to get like the basics in there, you just need your testing folder and you need your lib folder. Lib is where your code is stored, and test is where your tests are held. Test files should reflect the class they're testing with _test appended to the file name. So you had this morning with Kat, you had a dog class, right? Dog.rb. Your test file would then be named dog_test.rb. So name it the same as your class of which you're testing. Just put that _test appended at the end. In your test, you have to require the file for which you're testing. Okay, your test, when you run your tests, are not automatically going to know, and this is for Minitest. Minitest does not automatically know which class you're testing unless you provide the file where that code lives. So you do need to require any files of which you will be testing in that testing file. Run your test files from the root of the project directory. And this just goes into, we know how to run a file, Ruby, and then just state the file's path. So test / whatever the test name is to be able to run it. And that's kind of to get started, just like basic etiquette, naming conventions, and things like that. Taylor?
Yeah, I've seen require used and then also require relative. Which one should we be using, and I guess what's the difference?
Yeah, good question. I think this is something that will come up, you will see a lot. Since we are running our tests from the main directory, we're just going to use the require. If we were running our tests from the actual test file, like if we are living in the test directory and then running our tests, we could use a require relative. The require relative mainly means relative to where I am, like if I was sitting in that test file, relative to where I am right now, where is that class file located? So the path is going to be different if you use require relative or if you use require, because require is based off of where it is from the root level directory, whereas require relative is where is it in comparison to that exact file. So you're always going to use require.
Okay, that makes sense. Thank you.
Yep. That's a good question. And I was kind of expecting that to come up, so I appreciate that you asked that. All right, test convention with Minitest. So this is a little bit more with testing convention. So class name, you're gonna have, let's say we had the dog class. Your test is just gonna be called class dog test. Okay, so very similar to how we name our files, just append that test on the end there. You're also going to inherit from Minitest. And this Minitest, we're going to get into a little bit more, I think like week 4, week 5, about inheritance in modules. So right now the syntax might not look familiar to you, and that's totally fine. But pretty much what this is doing when we inherit from Minitest : test is it's bringing in a library of methods that we can use for our tests. And we'll see those methods in a little bit. So really what this gives us access to then is it gives us access to methods for testing. And we'll see those methods in a little. Your test names should start with the word test. That's a Minitest convention, and it actually will not work if you don't name your method with the word test first. So you need to have that word test in the front of your method name in order for it to actually work. And then I just added this in here too. Your tests, whatever you name your methods, it needs to be unique. Just like anytime you are writing code in a class, if you have 2 methods that are named the same thing, I think actually, even though I think it will take the first one instead of the second one. So similarly with testing, if you want all of your tests to run, you got to name them unique. Good practice to reference your method in the test name. So naming your test to be descriptive for what it's actually testing. So I might name my method, like if I wanted to test the attributes of the dog class, I might name my test def test it has attributes, something like that, to just be descriptive with what I'm actually testing. Cool. And then this last one here, this is assert equal. This is a method. This is an example of a method that would come from Minitest. Those are the methods that we're given through that Minitest test module to make sure that we are getting what we're expecting to get. And we'll go over this in a little bit. So again, a lot of words on these two. I just wanted to go over it and mainly jump into code to give you all an example of this, and then I'll separate you and you can try it on your own too, okay? Let's take a look at this. So let's write a test for this interaction pattern, IP interaction pattern. I couldn't fit it all in one line, so I abbreviated it. I never really see it abbreviated, but interaction pattern. And I'm just gonna copy this. This is taken from your lesson plan. So I'm gonna copy this just so that I can bring it with me to my actual code. So, and I'm just going to comment it out just so I have it all in one spot. All right. So let's go through kind of what we just mentioned with as far as testing etiquette goes and as far as Minitest convention goes too. So right now, can you all see my terminal okay? Cool. This side note, this is Benjamin Moo Pants. If anyone's been in Denver, I know everyone's from all over the place, but there is Benjamin Moore Paints, which used to be like an old paint shop that's now I don't know, apartments or something. And one time when I was in Turing, and I haven't changed this, when I was a student, we were all walking downtown and the R and the E in Moore was burnt out and the I in Paints was burnt out and just said Benjamin Moo Pants. And I thought it was hilarious. So this has always been my terminal prompt now, Benjamin Moo Pants. All right, so first things first, let's go ahead. I want to create, I have like a little place where I just put little directories to practice with during lessons. So I'm going to go ahead and make a directory for testing practice. And I'll go ahead and CD into that. And let me just open it up here so we can just take a look at it. That opened up on my wrong. There we go. Cool. Okay, so I have this. I'm in testing practice right now. To follow that testing etiquette, remember the first thing is we're always going to have a lib folder, we're always going to have a test folder. So while I'm in here, I'm going to go ahead and make a lib folder, and I'm going to go ahead and make a test folder. Take a look at it. Looks like I have them. Good. There's nothing in them, but they're there. Okay. Next thing is, I guess, let me take a look at this again. So we're working with students. So we're going to be making a student class eventually. So I'm going to go ahead and make a test first, because remember, we're starting with test. I'm not going to make the file in my library, my lib first. I want to start with my test, and that's eventually going to lead me to creating that file and creating any code that I needed. So in my test, little shortcut, if you just press A, at least for me in Atom, it'll come up here instead of just touching it from your terminal. Either way works. And again, convention for this test is I'm going to name it the name of my class and then append it with that underscore test.rb. Okay. And then in here, I'm just going to paste what I copied over. I'll make this a little bigger for y'all. So this is my interaction pattern that I'm looking to get working for this testing practice. And I think you all have seen these before. It's in your project right now. I'm sure you all have taken a look at least iteration 1 just to see kind of like how is that set up. And these interaction patterns are set up for you so that it kind of outlines what you should test. So again, starting kind of going over that like testing etiquette, Minitest convention, we need to require the file in our testing folder in order to test the class that we're expecting to have written code in. So I'm going to require in here /lib/student. I've not created that file yet, but I know that's where my code's going to live when I create a student class. In order to get Minitest to run, the one thing you'll need to do is you'll have to install the gem for Minitest. And mine's already installed, but I'm just going to run it here so y'all can see this. It's just gem install Minitest. One gem installed. And again, that's going to give you access to that library now. Now you can access that Minitest test module to be able to get those methods to be able to make those assertions in your test. The last thing you need to do in order to incorporate Minitest, you have this gem installed, but you need to make sure in your testing file that you require one thing really, two things if you want to get fancy. One is Minitest/autorun, which what this is going to do is when I say from my terminal, when I say Ruby test student test, hit enter, it'll go ahead and run all of those tests for me automatically. Otherwise, it won't run them automatically. So autorun will allow it so that when you just hit enter, when you run that test, it'll go ahead and run them all at once. The next one, which actually doesn't work for me, but I think will work for you. I think I just have so many versions of everything on my computer right now that it's not working. The next one is Pride. You might have seen this, but this just makes it nice and pretty. If y'all have used this before, it's like a nice rainbow dot collection if you get all of your tests passing, which is super fun and super nice. Unfortunately, you won't see that on mine. I have to figure out what's going on with it. Will, did you have a question?
Yeah, I was just wondering why on the two Minitest lines you don't have to enter like a folder path for it, or what does that do by default? Where is that Minitest folder looking?
Yeah, there is no Minitest folder. So it has access to Minitest information through that gem. So it's actually coming through the gem that we installed.
Okay.
And
So
anytime that someone else would want to run this, like if they, let's say push this up to GitHub, they pulled it down, I'd have to let them know, hey, you need to install Minitest. It doesn't come with this right now. It's something that you would have to install locally.
okay. Thanks.
Yeah. Cool. Let's go ahead. Let's take a break right now. And when we come back, we'll get into writing this test. So let's come back. I see a few hands up. We'll get to those questions and then we'll jump into this code. So let's do 5 minutes. I'll put a timer up here for you all and be back once that timer's off. See y'all soon.
Hey, Meg.
Yeah.
My computer was acting strange, so I was going to restart it. So is it okay if I drop off this call and join back before
Yeah.
that?
Is it kind of like, is it weird during this lesson?
Yeah, I'm not sure. Is it okay? I was just going to restart it and
That's
then.
fine.
Okay.
Yeah. And this is recorded too. So if you need to come back and catch up, you can.
Okay. Thank you.
All right, Will, did you still have a question? No? Okay, Garrett, question.
Yeah, for the gem, do we have to install that every single time we run a test, or is it just like we just install it once and then we're good to go?
You know, I
for
think that
future
I think you can install it at your name level directory. And then I think you'll
Okay.
have access to it everywhere, because I didn't have to install it for this in order for it to work. I was just showing you that I needed to
Okay.
install it. But yeah, I think just be aware that you might need to install it with everyone. I haven't had to though. So I think that I've installed it at a top level directory.
Gotcha. Okay.
Okay. So let's get back to this test that we have here. So name of the testing, or name of the class that we have here is always going to be the name of the class that we're testing plus that word test on the end. So we're going to say the class here is student test, and it inherits from Minitest test. And again, that's where our library comes from. That's where those methods come from that we're going to use in our tests. The next thing that I'm going to do here is I'm going to start by looking at this interaction pattern and kind of just like check off some things that I've tested. So the first thing, require lib/student. I've already done that up here, so I can get rid of this. I've already required that test or that file in my test, so I'm going to get rid of that in my interaction pattern and say good, done. Next thing here, so it's saying that like if we were in a prize session and we did student.new Penelope, what we should get returned to us is a student object with these two attributes. So I guess this is like a little funny, but I guess we can assume right here that like students are bringing cookies, right? They're bringing cookies to class. That's what we're going to assume for this little practice assignment. So what I want to test is I want to test that I can create a student instance. So more often than not, the very first test that you're going to do is it's going to be a def test it exists. No special naming here. I could say test I can make a student class or a student object or something like that. But I'm just going to say test it exists. And so in order to test that something exists, I need to actually try and make something in my test first. So I'm just going to grab this from my interaction pattern and say, here, let's make student, this local variable here, be the return value of hopefully what this .new should do is create a student object. So I'm hopefully creating a student object. And a method that comes from my Minitest test is assert instance of. So the way that most all of these methods will work, or at least the ones that we're going to use today, we'll go into a few more tomorrow, is you're going to have some type of assert. So in this case, it's assert instance of. And you're going to have two arguments that come after this. The first argument that comes is going to be what you expect it to be. And then the second one, separated by a comma, is going to be what it actually is. So for this, I'm going to say assert instance of the class student is what I would expect my lowercase student, that local variable. I would expect the lowercase student variable to be an instance of the student class. So this is what I'm expecting. This is what I'm testing. And again, this test is just making sure I can create a student object. I'm going to go ahead and run this test. So to run the test, Ruby test student test is my name. So I'm just going to run that test file. And we get, so let's go ahead and read through this. Trace back. So right here, this kind of gives me like where, kind of like the stack trace of where my error happened. If I keep going a little bit, I can see down here, require cannot load such file ./lib/student. I haven't created that file yet, which is why it can't load it. So I need to create that file in my lib folder. I need to create a student.rb. So I was having an issue here saying student file didn't exist. We created a student file. So let's see what happens now. Again, just taking like one little error at a time. I'm not going to go any further than that. Okay, we're getting a different error. let's see, let's read it through. Student test, tested exists. So this is telling me the test that it's failing on. Name error, uninitialized constant, student test student. So little hard to read here, but what this is telling me, uninitialized constant, tells me that something hasn't been defined. And what hasn't been defined yet is this student class. So I have the file for the student class, but I haven't actually come in here and say class student and said like, hey, this is the student class. I have a file for it, but it was never defined. So go ahead and run it again. I'm getting another error. Uninitialized constant student test. Oops, did I spell something wrong? I didn't save it. There we go. Okay. Wrong number of arguments. You all saw this earlier today. We talked about like the initialize method taking arguments, right? This might look a little familiar. Given 1, expected 0. And if we take a look at the stack trace here, we kind of start from the bottom and then move your way up. So down here, this is where it first hit the error, first had an issue. Had an issue in my tested exists test on line 8. So if I go to that, tested exists on line 8, it's having an issue with this line here. I can see that again here, tested exists, line 8. It had an issue when it tried calling new, which new under the hood, you all saw today, calls the initialize method. So that's why over here it's saying now it's having an issue with the initialize method. We haven't made the initialize method yet. So we need to go ahead and create that initialize method. And since we're passing in 1 argument, we need to make sure that our initialize method takes 1 argument as well. So in here, I'm going to say def initialize. And I guess, let me just do, again, one thing at a time. Let's say the thing that comes in here is a student's name. So in here, I'm going to say name, allowing it to take in 1 argument. That's really all it was having an issue with, right? Wrong number of arguments, given 1, expected 0. So we had to make sure that the initialize method was expecting 1 argument to come in. So that's what I did. That's all I did. And let's run this now. And it all passes. I haven't really done everything yet, right? I haven't created all the attributes for a student, but at least I can make sure that I can create a student object. The next thing that I would take a look at here, and I think that like we can kind of break this interaction pattern here into 2 different tests, because I can see that these student objects should have 2 attributes. And I can also see down here in these interaction patterns, I should be able to call student.name, get Penelope. I should also be able to call student.cookies and get that empty array. So that's part of that like attributes that come with the student. So I'm going to create another test here, and I'm going to create a def test. I'm going to put it, I guess I could do 2 different tests and say like tested as cookies, tested as a name. I'm just going to group them in together and say test it has attributes and just test them both at once. So again, I'm going to need that student object. So I'm going to copy that and just bring it down here. I need a student object in order to actually test something. And I want to make sure, I guess kind of looking mainly at these 2 here. I want to make sure that when I call, so the assertion we're going to use here, and these are the only 2 that I want to go over today. Again, we'll go over more later, is this assert equal. So I want to make sure, and again, this like assert equal, we're saying something that we're expecting, and then something that we're like actually testing. So we're expecting that when we call student.name, we would expect to get Penelope back. We see that? When I call student.name, that's my actual thing that I'm doing. I would expect Penelope. I'm also going to do this with cookies. When I call student.cookies, I want to make sure that I get an empty array back. So that's kind of what I'm taking care of here. So run our tests. Undefined method name for the student class. So, okay, let's just do what it says, and let's go ahead and create a method name. Some of you might be like, no, we learned a better way to do this today. We'll get there. but I'm just trying to get these to pass. All right, so I made a method name, but now it's saying, okay, you expected to get Penelope, but actually you're getting nil. Can I get a raised hand? Why do you think I'm getting nil? I made the method name. It didn't error out on that, but now it's saying I'm getting nil. Kate, why do you think I'm getting nil?
Because your method doesn't have anything to return. You haven't told it to return anything yet.
Yeah, there's nothing inside, so essentially what it's returning is nothing, right? So I need to tell it what to return, and this is what I want it to return, right? I want it to return the name that this student got initialized with. So if I try just calling name here, talked a little bit about scope, we'll talk a little bit about it more tomorrow. But if I called name here, I want you all to think for a second, what you think is gonna happen if I try calling this that got passed into my initialize method, if I try calling it here instead. And I'm gonna run it. Oh, we got a lot of red. I could keep scrolling, but that's what we got. What just happened? Any ideas? Hope, what do you think?
Well, you did not call the variable. You just called something name, but it wasn't a symbol or a string, so Ruby had no idea what to do with it.
Yeah, Ruby, that's a good guess. I think if I called this something else, it would have an issue with it. There's actually something else that's happening here. Jake, do you know?
You're basically calling the method inside the method and gives you an infinite loop, essentially.
Yeah, we got into like a little recursive loop right there. It's saying like, okay, call this method name, it called name, which called this, which called this, which called that. And so it like got into this loop here. So in order to get this name here, that's where you all got into this like add a reader. Oops, add a reader. Name, instance variable. And you set it equal to whatever came in. And now I can access that name from there. I need that I need that name to be able to be visible to my other method since it's an attribute that persists. And so saving it as an instance variable will help me be able to call it from there. So let's try that again. And it looks like, so looking at this error, undefined method cookies, it looks like now it's fine with the name. That worked just fine. But now we're having the same issue with cookies. So we need to make that method for cookies. And just for sake of time, I'm going to go ahead in here, and we know that we want this to return an empty array. So I'm just going to put an empty array there. And that passes. Okay. You all talked today. I'm just going to refactor this a little bit since we know it passes now. Now I can refactor it and make sure that it's still working. I'm going to put these as add a reader since we want this cookies to be an attribute on here and we want it to persist. I'm going to get rid of these methods here and make those two instance variables add a readers so that we can read them just as methods. We can call .name, we can call .cookies. And since we have those tests written already, let's make sure, oh, let's see, adder readers, no S, there we go. Y'all see that down here? Did you mean add a reader? It even just like told you. Thank you, Minitest. There we go, now it's working. Cool. For sake of time, and I wish that I would have had more time to let you all get going on a practice, I'm gonna skip over this part down here. And again, we're gonna continue this tomorrow a little bit so we can pick up with this more tomorrow. But I want you all to get some time practicing in pairs. So actually, Taylor, question, and then I'll give those instructions.
Yeah, it was just a quick question.
Go ahead.
I know there's maybe not necessarily a limit, but is there like a best practice to how many assertions you should be putting in for a single test?
As long as it is relative to what you're saying that test is testing, I think it's okay to put as many as you need in there. But as soon as it's testing something outside of the description of this test, I would make a new test.
Okay, thank you.
Good question, yeah. All right, I'm going to drop something in your channel. And let me find it. Okay. It's okay. I don't expect you all to get through all of this, but the first part of it is really similar to what we just did. So let me drop this and then I'll go over it. My formatting got all off. All right. And I'll just pull this up here too. All right. So you all have this right here. I just dropped this in your channel. I'm going to put you into groups of 2 or 3 people. Remember, make a directory, put a lib folder and a test folder in there. And then just like what we just did, you're going to require a file, test that you can have an instance of a person class, and then try and see if you can get to testing these attributes as well. Okay. Any questions on what I'm asking y'all to do in these groups of 2 or 3? All right, I'll pull you back with like 2 minutes of class left to see if we have other questions. Well, let me just make these groups. There you go. Hi, Mike.